What if I told you that a secret war is being waged right now, not with tanks or missiles, but with silicon? It's a battle for control over the future of every device you own. The prize? A tiny chip, just 2 nanometers wide. This isn't just about making your phone faster, it's about who controls technology, who holds the power, and who gets left behind. The companies you think are rivals, they're playing a completely different game. And one giant is already winning, thanks to a move so bold it's forcing the rest of the industry to scramble. In the next 10 minutes, we're going to break down this high-stakes race and reveal why the biggest battle in tech history is happening at the smallest scale imaginable. Before we get to the winners and losers, let's understand what's at stake. We're moving from the old way of making chips called FinFET to a revolutionary new design called Gate-All-Around, or GAA. Think of a FinFET transistor like a single-lane road for electricity. It works, but it can get congested. Now imagine a GAA transistor is a multi-lane tunnel where the flow of traffic is completely controlled. This new design lets electricity flow with less resistance, which means a huge leap in performance and power efficiency. Every major chip maker has their own version of this technology. TSMC has its nanosheet, Samsung has its MBC FET, and Intel has something called ribbon FET. This isn't just a simple upgrade, it's a complete architectural revolution. It's a strategic leap forward, and it's so expensive that it's creating a massive gap between a handful of elite companies and everyone else. So who is leading the charge? That would be Apple. They aren't just an anchor customer for TSMC, they're a partner. In 2024, Apple accounted for over a quarter of TSMC's total revenue. This isn't just a business deal, it's a symbiotic financial relationship. And Apple has used that immense power to make a decisive move. They've reportedly secured a massive portion, nearly half, and possibly more than 50% of TSMC's initial 2-nanometer production capacity. TSMC will ramp up to 40,000 to 50,000 wafers per month by late 2025 and double that by 2026, but the majority of those first precious wafers are going straight to Apple. This isn't a coincidence, it's a deliberate and strategic supply constraint. By locking in the most advanced chips, Apple is guaranteeing its upcoming products, like the A20, M6, and R2 chips, will have an unassailable performance advantage. It's a systemic strategy to fortify their entire ecosystem, from the next iPhone to the MacBooks and Vision Pro. This move has forced Apple's rivals into a frantic game of catch-up. First, Qualcomm. They were reportedly hesitant about the cost of the last generation of chips, but they can't afford to be left behind now. They're adopting a multi-foundry strategy to diversify their risk, reportedly considering Samsung as an alternative to TSMC. It's a pragmatic move that trades some performance for supply chain resilience. Then there's MediaTek. They've made an aggressive move by being one of the first to complete a tape-out of their 2-nanometer chip, signaling their intent to be a serious contender for premium capacity. And finally, Intel. They're not even in this race. Instead, they're making a massive bet on themselves. Intel has opted out of using TSMC's 2-nanometer process, betting that their own 18A node, with its unique PowerVia technology, will outperform everyone else. It's a high-risk, high-reward gamble to regain process leadership and establish themselves as a Western counterweight to TSMC. This isn't just about company rivalries, it's a global geopolitical battle. The cost of producing a single 2-nanometer wafer is a staggering $30,000, a 50% jump from the 3-nanometer generation. This chipflation is forcing companies to be more selective than ever, and it's also a direct driver behind the push to reshore advanced manufacturing. The U.S. CHIPS Act is a direct response to this, pouring over $52 billion into domestic manufacturing to reduce reliance on East Asia. TSMC and Samsung are building massive new fabs in Arizona and Texas, but this is a long-term challenge. It's not just about building factories, it's about creating an entire ecosystem, a skilled workforce, and a local supply chain. The 2-nanometer chip race has completely reshaped the semiconductor landscape. Apple has cemented an unassailable lead with its capacity lock-in. The foundry market is now a fragmented battlefield, with TSMC at the top, Samsung as the challenger, and Intel making a bold, independent bet. And finally, the global race for supply chain resilience has become a national security imperative. This isn't just a technical race to a smaller number. It's a complex battle for technology, supply chains, and power itself. The chips in your future devices are the result of a gamble that will determine market leadership for years to come. What do you think? Will Intel's big bet pay off? Let me know in the comments below, and don't forget to like and subscribe for more deep dives into the world of tech.